Okay, so we were doing some buffer calculations. And buffering capacity, the amount of H plus or OH minus we can add without having a significant change in pH. Obviously, the buffering capacity is not unlimited. Let's look at what we did up above, because the buffering capacity is determined by the magnitude of the acid and the base, the HA and the A minus. So if we come over here and look at where we added 0.02 moles of HCl. Well, what if we add 1 mole of HCl to 1 liter of the buffer? Okay, so we have our negative log of 1.8 times 10 to the minus 5, which we know from earlier is this. And then we have log of, and we have base on the top, so we would have 0.5 minus 1, and then we would have 0.5 plus 1. So if we do that, 4.74 plus log of 0.5 minus 1 divided by 0.5 plus 1. Okay, well, what we got there is log of negative 0.5 over 1.5. Okay. 0.5, oops, that's clear. 0.5 divided by 1.5 gives us 0.33, so it would be log of negative 0.33. And that's where we have the problem, because can't do log of a negative number. So this is more acid than the buffer can handle. Okay. Now, obviously, we don't have A minus and plus, so that should just be A minus. So when HA and A minus are equal, we're more resistant to pH change, and pKa of the weak acid should be close to the desired pH. That is how you pick which acid to use. Okay. You know what pH you need, so you find the one where the pKa is closest to your desired pH. Okay, let's do another one of exceeding the buffering capacity. So let's say we add 1 mole of NaOH to our 1 liter buffer. So this time we have our 4.74 plus log of 0.5 plus 1 over 0.5 minus 1. So we're not going to get a non-real answer this time because we're not going to have a negative number. Now, let me just find where I plugged this in before. There we go. Just going to bring this down because then all I have to do is change where my plus and minus are. Love these calculators. Oh, made a mistake on this one too. Oh, there's my mistake. I didn't clear my old answer. Gotta be careful when I cut and paste. All right, now that looks right. And again, look, a non-real answer. So again, we've exceeded our buffering capacity. That time I had too many parentheses. Nope, still can't do it. So what if we added 0.1? So that's going to be 0.6 over 0.4. I am trying to find one where it just shows that, hey, the pH changed. So, well, let's just clear this whole thing. 4.74 plus log of 0.6 divided by 0.4. There we go. Okay. So now we have 4.91. So we're starting to see pH change. And that was all I was trying to do with these examples, was to show you that the more acid or base, the more you're actually going to see the pH start to change. And if we add a whole lot, we're going to end up changing so much that we can't even do the math.